Hello.
Hey, good morning.
Hey, good morning. How are you?
Doing well.
Cool, awesome. Can you share a little background, like which level you are targeting at Amazon?
Yeah, I am. So I've been a software engineer about 2.5 years now,
Mm-hmm.
New York City, and I'm targeting the SD1 position at Amazon.
Okay,
I, I have my on-site on Thursday.
understood, understood. Cool, awesome. I think yeah, for SD1, it would be like some behavioral questions and some coding, right? Did
Yeah,
you confirm with the recruiter that you will be having object-oriented design?
yeah. It
Will
sounds like I'm gonna
okay.
have four rounds.
Mm-hmm.
One fully behavioral, and then
Mm-hmm.
three, LPs and technical.
Okay.
Um,
And in technical, it will always it will all be the coding or some object-oriented design. I know for SD1 there won't be system design, but
No
like,
systems design. I think one is standard data structures algorithms, one is
hmm
problem solving, and one is logical and maintainable.
oh yeah, so object-oriented design, logical and maintainable code.
Yeah, kind of
Okay,
the same thing, right?
yeah, understood. Cool, awesome. So yeah, maybe yeah. So we'll spend like 45 minutes on like actual interview part, and like I will keep like last 10-15 minutes on some feedback.
Okay.
Cool, awesome. So can you talk me to any situation where you had done something much more than your designated responsibilities? Like you were not asked to do something, but you identified that doing this would be helpful, and you did it.
Yeah. Um, yeah. Sure. So, I can actually talk about a story that kind of predates my my time as a programmer. This is
Mhm.
from when I was working with my family and my family business, which for context is a chain of women's clothing stores.
Mhm.
And so the problem that I identified that we could solve was that, the way that our inventory system worked, we
Mhm.
didn't have the ability to see what items were in what stores down to like a particular SKU. So, I wanted to implement this system using RFID tags. If you're familiar with the technology,
Mhm.
uh, radio frequency identification tags,
Mhm.
um, and um, this would enable a lot of things to happen within the company. It would allow our e-commerce site to basically ship from in store.
Mhm.
And it would also allow, when people are in the store, if they find a style that they like, maybe we don't have the size, we
Mhm.
can instantly see the closest store that has that style,
Mm.
make the conversion at that point, and then ship directly to the consumer. So obviously, this was a pretty major project. Took a lot of steps. Like I said, I was not the developer on this project, but I worked with our in-house developer to make it happen. And this required, many things. Obviously, we had to pick the hardware for, the printers of the tickets. We had to pick the hardware for the scanners.
Mhm.
We had to come up with reporting design for the salespeople in the stores, for our team of buyers, for the people in the warehouse or the processing, you know, the processing people.
Mhm.
And then, I had to come up with, standard operating procedures for all the people that process the clothing within our distribution center. I had to come up with SOPs for the people within the stores, about 200 employees in the different stores um, that would be now using these scanners to take inventory on a periodic basis. So, how to use the tools that we built on these scanners. And then also, there's a marketing aspect at the very end once this project came online to
Mhm.
train the customers retrain the customers that this feature was even available. Because prior to, the creation of this system, what a customer could do is they could request this. Can you check if this item is in another store in a different size or color? And that was a manual check where the salespeople at those locations had to go and manually check. And the execution rate was very low. I think it was like sub 5%. But, the total value of the goods requested was pretty high, definitely over 10K a week. Once this system was in place, I mean, it was definitely a long project, probably about 6 months from start to finish. But once it was in place, it translated to a lot of great results. We were able to sort of pinpoint theft more accurately than we had in the past. We were able to have this sort of direct from store to e-commerce fulfillment, as well as from one store to another directly. And then, this translated to, across 15 stores, about an extra 50,000 in sales per month, about 600,000 per year. Last time, and that was years ago when I really ran those numbers. But yeah, this was a really cool project that I think I identified the potential for, actually, while at a trade show here in New York City. Just getting exposed to the technology was when I really sparked my interest. And this is really also the project that kicked off my interest in software development. So I was working very closely with our developer, and then that, ultimately a couple months after that is when I started this coding boot camp here in New York City. So really an important project in my life.
Understood. Cool. Yeah. Thanks for sharing that. Do you have like any example where like you worked in a team and like your team members were like slagging a bit, and how you deal with that situation?
Yeah,
So
sure. So I think. Sorry, did you have another question?
no.
Yeah, I think I was kind of dealing with that pretty recently, actually. So for context, the project I've been working on recently is, I work at a hospitality company. So if you think about our user-facing product, it's sort of like an Airbnb, and then we have internal product that I work on as well, which is a property management system. So, we're kind of like an Airbnb, but the difference in the business model is that we actually like operate and lease these properties directly. And the project that I've worked on most recently was to build out our revenue management platform, which is basically simplified is a platform for setting up prices for each of these homes, across the calendar. So prices for each of the nights for each of the homes. And my involvement on the project was on the front end side, and I was working with one other front end developer and 2 back end developers. And yeah, I just, the whole project, I was kind of being periodically blocked by the back end developers. So, I would pretty much every week get to a point where I had done all that I could do without some advancement of the back end. So, obviously this was no secret to the team. We have our daily stand-ups. This was quite evident. So yeah, what I requested from my engineering manager and my director of engineering was just more support. So what we ended up doing is we brought in a third back-end developer to assist the developers, which ultimately alleviated these blockages and sped up the process. And was that the back-end team slacking? It's hard for me to say. It's hard for me to really evaluate the work that they were doing, and obviously maybe it was more complex than I give it credit for, but I didn't want to cast blame on anybody, so I just wanted to get the project done as quickly as possible. So yeah, I think bringing that third backend developer was a great way to keep things moving for myself. And ultimately we're about to wrap up this project now. We're sort of entering the testing phase, and we're definitely pretty much on schedule. It's taken about 2.5, almost 3 months, but we're definitely going to reach the testing phase within the deadline that was set for us. So yeah, I think that's an example where I felt that maybe someone was slacking, but either way we needed more help in that area.
Cool, awesome. Thanks for sharing that. Yeah, so let's move to the coding part. Let me just share the question. So let's say that you have a directed graph with n nodes, and those nodes are labeled like 0 to n minus 1. And like you have to find the length of longest path from all the nodes. Like, so if you consider this example, like there is an edge from 0 to 1, then there is an edge from 1 to 2, and then an edge from 2 to 3, and there is also edge from 4 to 3. So if you consider 0, the node 0, the longest path is of length 3, considering the 3 edges, 0 to 1, 1 to 2, and 2 to 3. That's why at index 0 there is 3. Similarly, for 1, the longest path is of length 2, from 1 to 2 and 2 to 3. So that's why 2 at index 1. And for 2, it's 1, because like just one single edge, 2 to 3. And that's why the 1 here. And there is no outgoing edge from 3. So that's why 0 for 0 at index 3.
Yeah, makes sense. So obviously we're dealing with a directed graph here. Can we have situations where there's a bidirectional relationship? Like, could the relationship between 2 and 3 have been bidirectional?
Yeah, so it should be explicitly specified by having 2 edges, 2 to 3 and 3 to 2.
Okay.
But yeah, but for simplicity, we can assume that there are no cycles.
Okay.
And thus there won't be a bidirectional thing between 2 nodes, because it will create a cycle. So for first version of problem, let's assume that there are no cycles.
Right. Okay. And we're outputting for each node, we're outputting the length of the longest path.
Yeah.
Okay. So I think, obviously we're constructing a graph here where a node points to its neighbors. And
so what are usual way of representing a graph inside a memory?
Yeah, I would probably just if I'm coding in JavaScript, just use an object where where a node, like node 0 here is just pointing to a set of other nodes. 1 maybe has some other nodes here, but probably just an object where the key points to another object. And yeah, I think like maybe it's a brute force approach, but we could, you said there will be no cycles. So, so basically like kicking off some type of traversal from the first node, we could basically, run the traversal on each of the subsequent nodes. Let's say 0 here had a 2 and a 3. And as we run the traversal, just keep track of like the amount of steps we've taken from the root, in this case 0, until the traversal can no longer progress, in which case we've reached sort of the end. Obviously, we could also check for cycles, but maybe we don't think about that today. And yeah, this would be sort of a brute force approach, where we would traverse 1, 2, and 3. we would see how far, basically how deep those go. And then we would take, the maximum length of all the different paths.
So what do you mean by zero having a list of like 1, 2, 3? It means that there is an age from 0 to 1, 0 to 2, and 0 to 3, or like how?
Yeah, I mean, obviously that's not what we're seeing in this example, but I'm just trying to,
Okay.
give another example of what the
Okay, okay.
structure could be.
Okay.
So,
So it means that like there is a node 0 with outgoing age to 1, 2, and 3,
yeah, is that a
right?
valid,
Okay.
would that be a valid case?
Yeah, that would be a valid case, yeah.
Yeah, so I feel like, yeah, that would be, we could probably use like a depth first search traversal, and that would be,
Hmm.
again, I feel like a little bit brute force. I think there's a way we could cut down on the amount of
So
work
you're
being
saying
done.
that so you're saying that we will run a DFS from each node?
We'll run a DFS from each node, but I think we could cut down on the amount of work being done, because if you think about the case of like 2 to 3, right?
Mm-hmm.
We know that or even 3, like 3, the answer will be, if we find a node that has no outgoing edges, we know
Mm-hmm.
that the answer will be 0.
Mm-hmm.
Similarly, we know that 2 will
Mm-hmm.
always have the answer of 1. So
Mm-hmm.
basically, we can sort of memorize these
Ah,
values as we
right.
uncover them, and then when we encounter them in the future,
Mm-hmm.
we can very quickly, like, had we already calculated the longest distance for 1, 2, and 3, it would just be,
Mm-hmm.
we'd just be setting 0 to the max of that plus 1. If that makes
Makes
sense.
sense. Cool.
Um,
What would be the complexity of this? Like,
yeah.
if there are V
So
nodes and E edges, what is the complexity of your solution?
I think that the space complexity would be, V nodes, E edges. I think the additional space complexity in our representation of the graph would be equal to basically the number of edges, I think, because each of
Mm-hmm.
the things held here represents a singular edge.
Mm-hmm.
And the time complexity of the memoized approach would be basically linear time, because as we
Linear
compute,
in terms of like nodes, or linear in terms of edges?
linear in terms of, I think, also edges,
Mm-hmm.
because as we run this depth first search, we're only computing the value of each node once, and then we're basically using that value to construct, like you could think of it as its parent's node or the node that points to it. So the computation should only have to be really done once.
Mm-hmm.
But also, in the case of 0 here, we'll have to look at, we'll have to just basically, once we've computed all 3 of these things, then we just need to look at all the child nodes and make a comparison of who has the longest, and then, add 1 to that. So I think I think maybe time complexity would be considered, O of, in this case, O of E, O of edges as well. Maybe O of E. Or maybe it
Will
is
it be
O
V
of,
plus E?
maybe, is it V plus E?
Yeah. So
V
what is the
plus E,
complexity
okay.
of like your DFS, like typical DFS?
In this case,
No, in any case, like what is the complexity of DFS?
the complexity of DFS, I mean, you're going to reach all of the nodes that are in that DFS, right? So in this case, that would be the V would represent the nodes, but we're calling, or no, the complexity of the DFS, I guess, would be the number of edges, but we're going to call the DFS on each node. Yeah, I guess I'm a little tripped up on the time complexity here, but
nope.
Hello? Yeah, so I guess the time complexity of typical depth first search, is it V plus E? Is it versus V plus edges?
Yeah, it's V plus E.
Okay.
Okay.
Cool.
I think this approach works. Can we move to the coding?
Yeah, sure. So you just stay in plain text if you want, or I could switch over to JavaScript, whatever you prefer.
I think you can use a plain text, like we won't be executing it.
Yeah, cool. So what are we doing here? We are finding longest paths, and that's taking in this array of relationships, right? So these are our edges, and as we described earlier, these like 0 to 1 here represents a singly directional relationship from 1 to 0. Are we also given like some n here that represents the number of nodes, or do we just have to infer that?
No, you can assume that that's given.
That's given. So we have our number of nodes here. So the first thing we want to do is translate these edges to some form of map, some form of object to represent the graph. So let's call that our map. And then we want to, we could also just loop from 0 to n-1 and basically populate this map for each value. Just say map at I is equal to an empty object, and now we can use this edge array to populate this map. So we'll say for let's start end of edges. So this is an array, so we can just iterate on it like this, deconstruct the start and end. We'll say map of the start to the end equals true. And we could also, let's make this a set in JavaScript, and it's a little bit more iterable, a little bit more easily iterable. So we'll say new set, and then we'll just say the map start dot add the end value to our set. So set in JavaScript is just it's like an object, but it only holds key values. So now we have this. We want to run. Obviously, we also need our result array, which is going to be an array of length n. We'll fill that with zeros for now. And then we need to build our DFS. So we'll call this const. So the parent function is finding all the longest paths. This is just find longest path. So we'll call this find all longest paths just to be a little bit more clear. And this is find longest path for a particular node. So that's going to take in a node. And we also need, like we said, we're going to memoize the values as we figure them out. So we need some memo here. I'm trying to think if we could probably reuse even the map to do that, because once we figure out the value, but let's just be a little bit more explicit here. So let's just say our memo is equal to an object. And, when we start this DFS, the first thing we want to do is say if memo has a value for this node, we just want to return that, right? So that's going to prevent the unnecessary work. And then we're going to say const, we'll call them children, is equal to the children is equal to the map value of this node. So this is all the next values we can go to, and we want to return the max of the find longest path for these children. So we're going to have to iterate through the children. So for let child, it's a set, so we can kind of pass this of the children. So the child is now, we're going to need to return the max value of all these children. So I guess we'll have to hold on to max here. We just call it 0, I think. And then we'll say, if find longest path of the child, or we could actually just say max is equal to math.max find longest path of the child and the max value. And then we are ultimately setting the memo node is going to equal max plus 1. And what else do we have to do here? So also, there's a case like in our example above, in the case of, I think it's the third node, we have this children will be basically empty. So if we call the DFS on that node, if memo node, if we don't have any length there, I think I'm going to change it not to be a set, but we want to return 0, because we'll be returning 0 here and then adding 1 to that 0 for, like, in the case of the 2. And I'm just going to change it. I don't think it's really necessary to use a set here. I think we can simply use an array and then just push in the end value. I don't think we're really gaining anything from using a set there. So I think this is a little bit more straightforward. Yeah. So, and then we need to call find longest path for basically every route. and push that into our result array. So push that into our result array, but also maybe we could just handle that. We could probably also do that at this point, right? Because this is where we're making a decision that is the longest path for that node. But we also need to, but I think that's fine if we just call it on every node, because, you know, if we've calculated that, like in the first, when we call it on 0, we should be doing the work for 0 to 3. And obviously we also want to call it on 4 as well, which will not be accounted for by any of the other computations. So I think it's fine if we just let I equal 0 if we call it on every root node, every starting point. We're just saying, you know, result I is equal to find longest path of I. And then that's what we want to return, is the resulting array, right? The output. Cool. So maybe you want to dry run this?
Okay.
Cool. So we'll use your input that you've given me. So that is, what is it? It's 0. Yeah, 0 to 1, 1 to 2, 2 to 3, 4 to 3. The resulting map will basically look like what you've drawn here with the arrows. We will call, we'll create this map of empty arrays. We will push in these values, so that map will basically look something like 0 as 1, 1 as 2, and so on. We'll call find longest path, which will memo node, return node, console. Let's just get the children until we get to the point. This will, so on when we call this on 0, it'll DFS all the way to our 3 node, at which point it'll say that has no length, because we never pushed in any outgoing edges to 3, so it'll return 0. Then at the 2, we'll get the math max will be 0. We'll memorize 2 to be max plus 1, which is 1. The 2 will become 1, the 1 will become 2, the 0 will become 3. And then here we are just, you know, this should really be an O of 1 computation, you know, after the first node for the next couple, because we're just going right into this DFS. It's saying if the memo node exists, return memo node. In the case of the 3, it's actually just going to return 0, which is what we want. And then when we get to 4, it's only going to go 1 level deeper. We'll get to 0 because 4 points to 3, and then we'll add 1 to that, and that's what we'll push in. So this should give us our expected output. Just trying to think now about different, you know, you said we don't have to think about cycles, but we could definitely protect against that if we wanted to.
And how will you do that?
So in the case of a cycle, like let's say here that 2 points to 3, let's say 2 pointed then back to 1, right, as well. So if that was bidirectional, if 2 pointed back to 1, when we got to 2, we would see in the children that we're iterating for 2, we would see 1. This wouldn't be sufficient because we haven't yet memoized the value of 1. So
Mm-hmm.
we would need to basically indicate like which DFS nodes are in progress.
Mm-hmm.
So, I mean, how could we do that? We could basically maybe just reuse this memo structure. Maybe when we kick off the DFS for a node, we
Mm-hmm.
set memo initially to like a -1 value or something. And then if we see that, I guess it depends how we want to, how would we want to handle that? What would that mean in terms of the longest path? Like if 0 pointed to 1, which pointed to 2, which pointed back to 1, would the answer for 0 still be 3? Because it just breaks when we get to the point of the cycle, or is the cycle like?
Oh yeah. If this would have been a case, like the output would be like infinity for 0, because like from 0 you can go to the
Oh,
cycle
okay.
and keep iterating in a
Okay,
cycle.
cool.
Similarly, the infinity for 1 and infinity for
Cool.
2.
Cool. So I think that's actually probably even easier to deal with if we just want to return infinity there.
Mm-hmm.
So when we kick off, like I said, when we kick off the DFS for a node,
Mm-hmm.
like up here, children map node, we could actually probably say just here, map node is equal to, let's just say something that would never be reached normally, like -1, and then, coming back around, if map of the node is equal to -1, we could
Mm-hmm.
just return infinity. Return infinity. So in the case of our, 1 points to 2, we get to 2, we set 1 to be -1, 2 points back to 1. We're calling the DFS on, in the case of 2, it'd be
Mm-hmm.
1 and
But
3.
what will happen, like in a normal case, let's say like there was no edge, will this map and when you visit like from 0 to 1 and
Yeah.
1 to 2, like when you are running DFS for 0, you will put a map of 0 and map of 1 as -1, right? But when you try to run DFS for 1, it will still be
Yeah.
minus
So
1.
if there's no cycles, return infinity. Yeah, I think we want ultimately all of these values, like you showed here, to become infinity, right? So, so this would return infinity, and then we'd
You also
ultimately
need
be
to
set
update a
it.
map in case of where you are returning the infinity. Should map also be
Okay,
required?
I see. So here we'd also have to say map of this node is equal to infinity, like that.
Oh no, not sorry, map. Your memo back to memo of node
Oh
infinity.
yeah, memo. And this would be, yeah, I said map here. I should have said memo for all these. Memo, not
Okay.
map, excuse me.
But like, let's say, can you dry run this example for normal graph, the previous example where there was no cycle? What it will return for this? So when you run a DFS from, when you call like this, find longest
Yeah.
path with 0,
Mm-hmm.
it will,
With yeah.
yeah,
So
what will happen? Yeah.
yeah, so it'll go past this. Obviously, we have not yet set the memo node to -1. The children in that case will just be the 1.
Mm-hmm.
we'll set memo of 0 to -1. Now we'll get to this 1, which just points to the 2. We'll set 1 to be the -1 as well. So 1 to be the 1 point. Now we're on the 2. 2 becomes -1. And now we get to the 3. The 3 points to nothing, so it'll return to 0. The 2 will have a max value here of 0. We'll overwrite the memo node for 2 to be 1. 3 will be 3 will
For 3,
be.
you will write 1, right? Because your max is 0, and you will write, it won't be updated.
Yeah,
So
I guess we'll actually never update the memo for 3 because we're just hitting this before we even need to, which does basically the same thing, right?
Okay.
Oh, this is map, not memo. Sorry, I'm getting a little jumbled with map and memo. So if this has no outgoing
There is
edges,
this memo, right?
return.
There is also, okay, got it. Map
We
is
should call map's a tough name. We should call this like edges or something.
So that's fine. Like, yeah, for now, that's fine.
So yeah, and then 2 will become 1. The 2 will. I think we need to. What I'm not doing here is maybe not returning memo or max +1 is what we need to do. Maybe I forgot, right? Because we need to return. Yeah, I have to return here. I think that's what I'm missing.
Understood.
Let max for let's show max find path. Set the memo and then return. Yeah, we definitely need to do that, right? Because otherwise this evaluates to undefined in all the cases except for this. It's the only place when we're first doing the computations. Obviously, secondary computations, this would be fine, but in the initial computation, you still need to return something. You need to return that max +1.
Understood.
Yeah. So, do you think there's any issues with this in our non-cyclical case?
No, sorry, I missed this case. Like, okay. So now when you are done with 2, what would be the value of memo of 1 updated to? Will it still be -1 or will it be updated?
So 2 will return the max +1, which is 1, and then 1 will be the max will be set to 1. We'll set the memo node to max +2, which is 2, and it'll return 2, and so on. 0 will become 3.
Okay. Yeah, got it. I think this should work. Cool. Yeah, that's it from my side. Like, let's move to the feedback part of it.
Okay. Awesome.
Yeah. So, regarding your leadership principle questions, I would like you to introduce some more numbers. Like, you can talk about when you said the example of your family business, you can explain what was the impact of this project on overall sales, overall revenue. You can talk about in terms of percentage, like it improved your, or you can talk about if you have customer feedbacks, if your customer feedback improved or your revenue or your sales improved. You can talk about that, like how much it was improved.
I think I did give a statistic on revenue. Did you not catch that or?
Maybe I lost it. Like, what was the part? Like, what was stats?
Yeah, I said, this translates to an extra 50,000 in sales per month, between
Uh,
in-store and e-com, 600,000 a year.
oh, okay. Sorry. Yeah, sorry, I lost it. Maybe like you can talk it in terms of percentage. That would even be better.
Yeah.
But if you're already covering it, that would be that's good. Sorry, I missed it somehow. Yeah. So apart from that, like, and there is no issue of using your example from non-coding thing. It's just
Yeah.
about like having those examples ready. So my session would be like to create an Excel sheet with like few leadership principles and one or two examples against them. So like my session would be have to have that example, those examples handy so that you don't need to like remember during time, and you definitely cover like so that like you definitely cover important points from each example. So
Mhm.
yeah. And that's it about the behavioral part. In coding part, like I really like you identified the important clarification question that whether graph has cycles or not.
Mhm.
That's important. Like you identified that, so keep doing that. And in second thing, like when you're talking about approaches, my suggestion would be like follow your like once you shared the approach, follow that with your complexity analysis.
Mhm.
To talk about like what would be the complexity of your approach, and do ask
Mhm.
like whether it's okay to execute this. Like there are two reasons behind that. One is like he will know, like interviewer will know that you can do the complexity analysis, and second, there won't be a time waste to in a situation where like you are optimizing for already optimized solution, or you are writing or you are coding an approach which is not optimal, and interviewer wanted you to code optimal approach. So yeah,
Mhm.
whenever you share the approach, do follow that with the complexity analysis, and do ask
Mhm.
like whether interviewer wants you to code this or not.
All right.
Okay. So yeah. So the and like do you, I think like you struggle a bit with the complexity analysis of DFS. My
Yeah.
suggestion would be like to have one cheat sheet ready with you, like maybe just to revise it, like for
Yeah.
well-known algorithms, like what would be the complexity of those, like algorithms and data structure, like BFS, DFS, Digestra,
Right.
or yeah. So have those complexity handy, and also for like some well-known algorithms like binary search tree, binary tree, balanced binary search tree,
Mhm.
binary heap, like how those complexity priority queues, how those complexity is handy for you,
Mhm.
so that you can revise with before your interviews. So yeah, yeah, in coding, like I think one feedback I can go, I could identify is like you could have created a modular like another method to create to build a graph like from the edges.
Mhm.
Would have been like some other method, but that's fine. Like that's totally okay. Once you're done with the code, do talk about the test cases. Like what test cases comes to your mind. Like will you try maybe like for this example, you could have said that a graph with a cycle, graph without a cycle, a
Mhm.
disconnected graph, a strongly connected graph. You can talk about a few examples here. A graph with no
Mhm.
edges, graph with just single nodes. So those you can talk about like I will like to test against those graphs. So it shows that you do care about your code, and you do think about your complexities. You do think about the quality of your code by thinking about test cases. So my suggestion would be like to do talk about test cases once you are done with the code.
Cool. Yeah. Yeah. Very good.
Yeah, and I think yeah, you were you did easily converted your code in idea into code, so you have a good practice of implementation. So that's a good thing. Keep doing that. Um, yeah, and you were able to answer the follow-up question also, like when there are cycles. So yeah, I don't have any like any other improvement feedback on coding. Like you did well in coding and behavioral both. So in my view, you are you are ready for the interview, and like you just need to. My only suggestion would be like to brush up like those examples, or even
Mm-hmm.
have written handy.
Mm-hmm.
That
Um,
have you already created the any document for those examples?
of the LPs,
Sorry.
do I have the document of the LPs?
Yeah, yeah. Yeah.
Yeah, I have. Yeah, I have it
Oh,
in
nice.
more of a in more of like a Word format, but yeah, I have about
Oh, nice.
10 examples.
Oh, nice, nice.
Yeah,
And
I guess
have you written
at
them
this
in a star format, like situation, task, action, and
yeah,
result?
situation, task, action, results. I try to highlight
Mm-hmm.
numbers, and I even have like like what I learned or takeaways for some of them. Um,
Hmm.
I have them tagged by the LPs. Maybe I'll put them in a more simplified format correlated to the LPs. But yeah, I think the LP stuff is now what I'm trying to focus on. Um, I think
Understood.
I'm okay for the technical stuff. Just like
Mm-hmm.
I think I'm most nervous for the round that's like no technical and all LPs.
Uh,
Um,
Understood.
you
And
know,
what about like your object-oriented design, like clean and maintainable code around the round with clean and maintainable code?
yeah, I feel pretty good about that. I've been doing other interviews on this platform. I've done a handful of those at this point. Feeling obviously a little bit harder to practice than the data structures algorithms type stuff, but feeling pretty good there as
Okay.
well. Yeah, just really trying to make sure. I feel like with the LP stories, sometimes the story could actually get you into trouble, or could just open yourself up to like too many complexities and questions. So I'm just trying to really make sure my stories like make sense, and I don't get too confusing. Did my initial story? I guess a couple questions on that. I haven't told that one before, but obviously it's a big project, and I feel like it's a great example of like diving deep in ownership and even like
Mhm.
customer stuff. I don't know. What did you think about that story?
Yeah, I really like that story. And yeah, I don't find any confusing part in it. You did explain
Mm-hmm.
the context, like you did talk about like when was this, and what was your role. You did identify, you did make sure that you are not the developer, but you're oversighting it. So yeah,
Mm-hmm.
I yeah. So I think like you had a good presentation there.
Mm-hmm.
Yeah.
Um,
Like,
yeah.
are you brushing up those solid principles for your object-oriented design round?
I think I read an article about the solid principles, uh, but yeah, like in my uh, in my practice interview the other day, I
Mm-hmm.
definitely missed a piece that was the whole point of the whole thing that I got caught up on was just basically making a class and extending it into a few other classes. So I think that was definitely a good lesson in like extensibility, and I haven't uh, practiced that quite as much. So I think just remembering that like the whole point of the logical and maintainable part is probably going to be like extending classes and just keeping inputs flexible. Is a good thing to keep in mind. Like the question will probably be asking that in some form, um, so not to miss it.
Okay.
Um,
So yeah, I have shared a YouTube link of video which helped me to understand solid principle a lot.
mm,
Um, it's on the top. Like maybe if you get some time, like do go through it. Like it will be helpful for you.
yeah.
Uh, yeah, and do talk about like along with solid principles, do talk about like principles like composition over inheritance.
Hmm.
You might be aware about this, right?
Yeah.
Yeah. So yeah, like the expectation in this round is like it's not like you there would always be some subjective part, right? So there is some other way of designing the classes, but the expectation is that you can break overall things into components, and you can talk
Hmm.
about interactions between components, and you know a few things about like object-oriented design. So do like try. My suggestion would be like to do be more vocal, like um, talk explicitly like how you made this choice. Like you chose composition over inheritance. You do explicitly verbal about it, and to
Mm-hmm.
talk about like okay, I've this class is single responsibility one, so that like interviewer knows that you have those skills which it takes. So yeah,
Mm-hmm.
yeah, I think yeah,
Awesome.
I'm pretty positive about like overall outcome. So all the best for your actual interviews. Yeah,
Amazing, man. Well, this was a great session. Definitely stars all around. And yeah, thank you again, man. I'll do my best.
awesome. Yeah, all the best. Bye bye.
All right.
Thank you.
Thanks.